All right, we're back. We are on the first page of notes 10 of math analysis. I think it's page 104. So if you made it this far, good deal. And we're going to talk about solving oblique triangles. So the first thing we need to know is, what is an oblique triangle? Well, an oblique triangle is a triangle that does not have a right angle. So if it's a right triangle, then we would just use normal trig on it. This is going to be about oblique triangles, but it turns out that the entire process involves breaking your triangle down into right triangles. And then you kind of get a generalization from there, and then you don't use the right triangle thing. So that's what we're going to do. First, we're going to take a triangle that doesn't have a right angle. We're going to break it down into two triangles that do have right angles, find a relationship, go from there. So let's see if we can do that. So there are really two ways you deal with this. One is called the law of sines. One is called the law of cosines. We're going to start with the law of sines, which is kind of the weirder of the two, to be honest. It's a little more up in the air. But anyway, let's see if we can do it. So step one, we want to establish sine of A over A equals sine of C over C. And we have this triangle here. So what I'm going to do is I'm going to label this thing as H. And the reason that I did that was that now I can kind of like talk about this thing. So here, this is C because it's opposite angle C. This will be A because it's opposite angle A. And then B would be down here, but I don't think I'm going to need that for this. So I'm not going to do that. So let's focus first on angle A. So for angle A, the sine of A, so, ooh, what was that? Let's see. Let's try that again. All right, the sine of A. Sine of angle A is opposite, which is H, over hypotenuse, which is C, which means that H is equal to C times the sine of A. Okay, so that's one thing. And then I'm going to focus on angle C. So for angle C, I'm going to say the sine of C is H over A. So the sine of C is H over A, which means that H is A times the sine of C. Okay, so now I don't really need the triangle. I have two things that are equal to H. So they're both equal to H, which means they must be equal to each other. So we'll say that C times sine of A, C times sine of A is A times sine of C. And then what I can do is divide both sides by A times C, I guess, if you want to think of it that way. So the sine of A over A equals the sine of C over C. All right, so that's actually like a really interesting result, that in this triangle, which is a random triangle, the sine of angle A over side A is equal to the sine of C over side C. I don't know. So let's see if we can do the next one, which says that we need to establish sine of A over A equals sine of B over B. We're gonna do it in exactly the same way. So let's go to the triangle, label some things. So I'm gonna call this H again. So H is the height. It's from one side perpendicular to the opposite side. So we have that. And then this will be A, this will be B. And again, this is C, but we don't need it, and it would be complicated to like figure out what to do there. So we're just going to ignore it. Let's focus in first on A again. So in this case, the sine of A is going to be opposite over hypotenuse. So it's H over B. Sine of A is H over B. In this case, so sine of A is H over B, which means that H is B sine of A. Sine of A. And then we need the other angle. So let's go here. So for B, sine is going to be opposite, which is H, over hypotenuse, which is A. So sine of B is H over A. And you can kind of see how this is going. I mean, hopefully. H over A. So H is A times the sine of B. So what's really interesting about this to me is that the law of sines isn't really hard to come up with. Even though it's like a really weird result, well, I think it's a really weird result. Like, I don't think I would have guessed that it worked this way. but it turns out that it does. So, and it's pretty straightforward to apply. There is one sort of tricky, you might say ambiguous situation that we're gonna have to deal with, but here I get sine of A over A is the sine of B over B. And that means that if you look at it, the sine of A over A equals the sine of C over C. The sine of A over A equals the sine of B over B, which means that all three of those are equal to each other by the transitive property. That is the law of sines. So law of sines tells us, and I don't know what, I'm going to highlight the whole thing, but I mean, obviously, you know, it's in a box. Maybe I'll highlight the box. See if I can do that. I wanted to do it like really nicely. I hate the way that when you overlap the highlighter, I mean, it's just picky, and in the real world, this happens too. I hate how it like gets darker when I do that. But anyway, it's sine of the angle over the corresponding side equals sine of an angle over the corresponding side, and so forth. Also, you can flip them over, and you can have side over the sine of the angle, side over the sine of the angle. Just depends on what you're trying to solve. So that's the derivation of the law of sines. So that's where it comes from. Now it's going to be about like, when do we use it? How do we use it? What's tricky about it? So I'm going to just finish this page, I think. Congruence theorems. Oh my God. Usually in class, I just crowdsource these. So we've got congruence. So think back, right? So side, side, side is, I think, the one that, well, that's the one I always remember. Side, side, side. Side, angle, side. Angle, side, angle. Angle, angle, side. Angle side angle and angle angle side are really the same, because if you know any two angles of a triangle, you automatically know the third. So if you know like two angles and then a random side, you automatically know the third. So you really just know angle side angle. But whatever, it's one of them. And then there was actually another one, which was HL. But this only works. This is only a right triangle. And since we're not interested in right triangles at this point, we don't need that one. So which of these work if we are going to use this relationship? So what we need is, we need definitively a angle side pair, right? So we need to know an angle and the side opposite that angle. If we know that, we can potentially use the law of sines. So which of these don't give us that? Well, side, 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 we don't know any angles, right? So for side, 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 we would have like, I don't know, 1, 2. So that's not a triangle. This is not going to work. Side angle side. So side angle side means you know that two sides and the angle that's in between them. But what we don't have is, we don't have like this angle and the side opposite, or this angle and the side opposite, or this angle and the side opposite. We don't have enough. So this is out. That is not one where we can use it. Angle side angle. So for angle side angle, we know like this, this, and this, I guess. So now this one, it's a little tricky, because when you look at the picture, we don't have what we need, but when you think about it, since we know this and this, we automatically know this. So this is one that we can use it for. So this will go, that'll go with the law of sines, no problem. And then angle, angle, side. So angle, angle, and then like side, right? So this is actually the most direct one, because we know an angle and the side opposite that angle. That's textbook law of sines, so it'll work for this. So these are the ones that we're going to use the law of sines for. And the other ones, we're going to need something else. Turns out the other ones that we're going to need are the law of cosines. So, so which congruence relationships give us enough information to use the law of sines? The answer is angle side angle and angle angle side. And basically, I'm just going to say, if you have an angle side pair. So if you know an angle on the side opposite that angle, law of sines. All right, so I'm going to stop this here. We didn't really do anything, I would say, in this particular video on this page, but this is where it all comes from. I think it's really important to know where things come from before you start using them. So I'm going to cut the video here. I'll be back in the next one, and we will do some problems. So I will see you there.